vector A, vector B. This is the component of a vector B along vector A. That is a scalar vector A dot vector B is equal to A times B times cosine theta. Vector A times vector B plus vector C is equal to vector A dot vector B times vector A dot vector C. That is the distributive law of dot product. Dot product is also called scalar product because the result is a scalar. And for the distributive law, we have a geometric proof. This is vector A. This is vector B, vector C. So this is a vector B plus C. Let's first look at the left part. Vector A dot vector B plus vector C. That is vector A dot vector B plus vector C equals A times B plus C times cosine alpha. Alpha, this is the alpha. Alpha. So the component of a vector B plus vector C along A, this part. This part. Okay. Then let's look at this part, the right part. Vector A dot vector B plus vector C dot vector C, vector A dot vector C. Okay, vector A dot vector B plus vector A dot vector C is A dot times B times cosine vector B, the component of a vector B along vector A at this part. And the angle here is beta, cosine beta, plus vector plus A times C times cosine vector C along vector A is this. This is a vector C along vector A from here to here. Okay, so this is the angle here is gamma, and this part is the absolute value of vector C times cosine gamma, because this is vector C, so this is vector C. Here is vector C. And this is perpendicular to vector A. This is perpendicular to vector A. So here I make a rectangle here. Make this line is parallel to vector A. So this is the rectangular. So this part, this line, is equal to this line. Okay, this is a so this line is perpendicular to this. Okay, this is parallel to vector A. So this vector, this is vector C. Vector C, the component of vector C along vector A, is this part, and this is the same with this is okay. This is also gamma. So this part is vector. The length of this line is absolute value of a vector C times cosine gamma. So this is this, and this is this. So here vector, so absolute value of A times absolute value of B times cosine beta plus cosine gamma. Here, these two parts actually is the same with this part. So that is this part. So these two are equal. Okay. This absolute value of A. This part, this is this, and this part is this. These two added together is this. Vector B and vector C along vector, the component of vector B and vector C along vector A. So they are the same. Plus along vector A. So that is vector A times vector B plus vector C. The left part and the right part are equal. So we have proved the distributive law of a dot product. Okay, so with this law we can calculate the value of any two of the dot product of any two vectors. Here we have vector a vector x. We have a vector A. Vector A, we can have three axes. X, Y, Z. And so the unit vector of along axis X is I roof. Unit vector along axis Y is J roof. Along vector Z is K roof. So we have a vector A. Vector A is a vector in a space, and we can have a vector. We have a plane perpendicular to the plane of X and the Y. So here X and the Y. This is vector A. Here okay, so this is so we have here a plane. We have then along vector along axis Z we have a vector A. So A is equal to AX I roof times AY J roof times AZ K roof. Okay. So this is any vector in a space along axis AX, axis Y, and axis Z. We can form any vector using these three axes. So with the distributive law we learned above, we proved above, then we can calculate any dot product of two vectors. The same for vector B, we can write it like this. So the dot product of vector A and B is vector is AX, AY, AZ times BX, BY, BZ for distributive law we can get the result by timing these components one by one. AX I roof times BX I roof. AX times BX times I roof, B roof. They are unit vectors, so the absolute value of these two unit vectors is 1 times cosine 0. Cosine 0 is 1. It's also 1. So this is 1. Okay. And then AXI roof times BYJ roof. I and J, they are perpendicular to each other. These two vectors are perpendicular to each other. So the angle is 0. The angle is 90 degrees. So the cosine 2 pi over 2 is 0. And this one also, this part AX I roof times BZK roof is also 0. Okay. This is also 0. Okay, this is 0. Okay, so only one part, one component. For the second part, J is perpendicular to I roof, so this is 0. J and J, AY times BY these two, j roof times j roof 1, and this one j roof times k roof 0. So the last one, az times bxi roof, this is 0, 0, az times bz times 1. So the result is ax bx plus ay by plus az bz